Hello! Today we are going to be looking at finding rational roots of polynomials. Before we can find this, we must understand what a polynomial is and what a root is. A polynomial is the sum of several terms. The polynomials we will be working with will have a coefficient of a whole number and will be multiplied by a variable to some power. An example of a polynomial is x squared plus 2x plus 1, or 5x cubed plus 2x minus 7. Now the root of a polynomial is what we plug in for x such that the equation equals 0. For example, the polynomial x squared minus 1 has a root of 1. When we plug in 1 for x, we get 1 squared minus 1, which is 1 minus 1, or 0. A rational root is a number that can be written as a fraction. In our example, 1 is a rational root because we can write it as 1 over 1. For smaller polynomials, it may be a bit easier to guess what these roots are, but for large polynomials, it may be a bit difficult. So, let us take a look at this polynomial as an example. What kind of roots are possible for this polynomial? Let us suppose that this polynomial has a rational root. Since it is rational, we can write the root as a fraction of c over d, where c and d are some whole number. So when we plug in c over d for x, we get the definition of a root. Then 3 times c over d to the third plus 2 times c over d to the second plus 5 times c over d minus 2 equals 0. By using our exponent's properties, we can also write this as shown here. So now, what can c and d be? First, let us look at what c could possibly be. Let us get rid of the d's for now and look at the polynomial 3c cubed plus 2c squared plus 5c minus 2 is equal to 0. So let us add 2 to both sides. Now on our left-hand side, every term is being multiplied by c, so we can now factor out this c. Therefore, we can see that c must be able to divide 2, and so c can be a factor of 2, which are positive or negative 2 and positive and negative 1. Now, let us look at what d could possibly be. Let us get rid of the c's for now and look at the polynomial 3 divided by d cubed plus 2 divided by d squared plus 5 divided by d minus 2 equals 0. These fractions are a little hard to work with, so we are now going to multiply the left-hand side and the right-hand side by d to the third to cancel out the fractions. Like we did with c, we will subtract 3 from both sides. Now, it can be seen that all the terms on the left-hand side are being multiplied by d, so we can now factor out this d. Therefore, we can see that d must be able to divide negative 3, and so d can be the factors of negative 3, which are positive or negative 3 and positive or negative 1. Now, we know all the possible c's and d's for our root. All the possible roots will be the combinations of these c's and d's. So these possible roots are positive or negative 2, positive negative 1, positive negative 2/3, and positive and negative 1/3. To finalize which numbers will be our rational roots, we now just have to plug them in for x and see what we get. If it produces 0, then it is a root. So when we plug these numbers in, we get these. 1/3 is a root of the polynomial. So, to find the rational roots of any polynomial, we can use the principles we learned in this example. The possible rational roots of any polynomial are the positive and negative factors of the term in the polynomial without an x, or the constant, divided by the positive and negative factors of the term with the largest x. Once you find these possible rational roots, you just need to check to see which ones will produce 0. So let us give it a try. Pause the video to try and find the rational roots of the following polynomial. Our possible rational roots of this polynomial are positive and negative 1, 2, 3, 6, 1/3, or 2/3. And after we plug them in for x, the rational roots of this polynomial are found to be negative 2/3, 1, and 3. For more information, check out this textbook online. Thank you for watching, and good luck finding your roots.